Hello students, today I will discuss one topic from the subject physics, that is Newton's laws of motion. Before starting this topic, I would like to introduce myself. My name is Parul Kumar Srivastav. I had completed my BTech in mechanical engineering. After that, I had completed my post graduation in machine design. Then I had started teaching in an engineering college. Okay, so Newton's laws of motion. Newton's basically given three laws of motion. Newton's first law of motion states that if a body is in motion or a body is in rest, then the body will remain in that state until and unless an external force or external agency is not applied on that particular body. Okay, so basically Newton's first law of motion defines defines about the force. Okay, because if you will see the definition of the force, it states that it is an external agency. A force is an external factor which is applied on any object, then the position of that particular object is changed. Okay, or that external factor is trying to change that particular position of the body. Okay, so the body may be in rest or the body may be in motion. So Newton's first law is called, if the body is in rest, then inertia of the rest. Because inertia is a term, if you will define this term inertia, it means whatever the position of the object. Suppose this object A is rest on a table, okay, and it is in rest. So what it will try to remain in that particular position. So that is called inertia of rest. If you will define inertia of motion, suppose this is a ball, cricket ball, okay, it is moving in this direction with velocity v. Okay, so it will try to remain in that particular direction until and unless an external force is not applied, an external factor is not applied on that particular body. That external factor is called force. Okay, so I hope that this law is clear to all of you. This law basically, it is also called law of inertia. It may be rest or it may be in motion. So statement is, if a body is in rest, then it will remain in rest. If a body is in motion, then the body will remain in motion until and unless an external force is not applied on that particular object. Okay, now Newton's second law. Now see Newton's second law. Newton's second law. Okay, let's start with the Newton's second law. Newton's second law of motion. Okay, Newton's second law of motion. Newton's second law of motion states that whatever is defined in Newton's first law, that is force, and the magnitude of that particular force which is applied on a body, that is directly proportional to rate of change of momentum. That is directly proportional to rate of change of momentum. Okay, so if you will see, if you will see, you will find that F is directly proportional to rate. Rate means that particular property changing with respect to the time. Okay, so if you will see, you will find that F is directly proportional to d upon dt of P means m into v. Okay, momentum means m into v. Okay, now you know that m is a constant. Mass is always remains constant, so you can take it from this derivation. So it will remain d upon dt of velocity. The rate of change of velocity is called acceleration. The rate of change of velocity is called acceleration. Okay, so you can write that F is equals to k ma, where k is the constant and it is defined, the value of k is defined on the earth, its value is 1. Okay, so this is Newton's second law. Okay, see, this is Newton's second law. Okay. So next is Newton's third law of motion. So Newton's third law of motion, basically it is action reaction, means whatever the action, whatever the force applied by one object to another object, equal and opposite force is applied on the first object by the second object. Means suppose there are two objects A and B. Okay, or you can consider this case, there is a surface on which a book is kept. Okay, there is a surface on which a book is kept. Because of its mass, a force is acting on this surface because of the object weight, or sorry, mass you can say, or weight you can say. So mass, you will not say mass, it is weight, okay, because of gravity m into g, that is called weight, okay. So it is acting in downward direction, means on this surface, and the surface is offering an equal and opposite force on this object, that is called reaction force, okay. So the statement of the third law of Newton's third law, that is, if an object is applying a force on a particular body or particular object, equal and opposite force is applied by the body on that particular object, okay. That is called Newton's third law of motion. So you can see here, okay. Now if you will see, or you can draw the free body diagram. So this force is acting on the surface and reaction force is acting on the object by the surface. These forces are equal and opposite, means R is equals to mg, or somewhere in some books it is also represented with the N. The one important point to be noticed in this case, that action force, that is mg, and reaction force, that is R or N, that two forces are equal and opposite, equal in magnitude and opposite in direction. But the point is that these two forces are acting on the two different surfaces, means weight is acting on the earth and the reaction force is acting on that particular book, okay. So this is Newton's third law of motion. So once again you can revise whatever the Newton's three laws related to the motion. That is, first one is the law of inertia, means if a body is in rest then it will remain in rest, or if a body is in motion then it will remain in motion until and unless an external agency is not applied on that particular body. That external agency is called force, okay. Second law of motion defines the magnitude of the force, means the force applied on a particular body or object that is directly proportional to the rate of change of momentum, means F is equals to ma. That derivation I have discussed. Now the Newton's third law of motion, that is action reaction law. Whatever the action by one object to another body, that similarly equal and opposite reaction by the second body to the first object, that is action reaction law, okay. So these are the Newton's three laws related to the motion. Basics I had discussed. I hope that Newton's three laws will be clear, means you are able to understand what are the Newton's third law of motion. We will discuss further the remaining topic. Thank you very much.